Good morning, students. Students, by now you must have seen that we have done two types of a practical with you. The first one was the titration, in which we did the ferrous ammonium sulfate versus KMnO4 and the oxalic acid versus KMnO4. The second was the organic analysis, in which we did various types of organic compounds. Now today we will be doing mixture analysis with you, student. Now as far as the mixture analysis are concerned, you will be given a salt, and that salt will be containing one cation and one anion. Am I getting clear? Now the various anions, these are called as acid radicals. The anions which are in the syllabus, these are carbonate ion, sulphite anion, sulphide anion, nitrite anion, nitrate, chloride, bromide, iodide, acetate, sulfate, phosphate and oxalate anion. Out of these 12 anion, one will be given to you, which you have to identify. And you are the luckiest one. It is only the last year that the board has decided to give the one anion. Otherwise, earlier we used to have a two anion to identify, which was really a tough practical. It was a tough practical to do. Then you have to identify the cations. Cations are the basic radicals. The cations in the syllabus, which is to be analyzed, are divided into the various groups. Remember, these are not the periodic table groups. The various groups in which the various cations are kept. In the zero group, this is not the group of a periodic table. We have to identify the cation, which is a ammonium ion. Am I getting clear? In the group number 1, we have to identify the lead ion. In group number 2, we have lead ion and the copper ion. Am I getting clear? In the group number 3, now just see, if you are able to identify the lead ion in the group number 1, no need to carry out the test in the group number 2. In the group number 3, we have a ferric ion and aluminium ion. Am I clear? In the group number 4, we have manganese, nickel and the cobalt ion. Am I clear? In the group number 5, we have barium, strontium and the calcium ion. In the group number 6, we have a magnesium ion, which is to be identified. Out of all these cations, you have to identify one. So the salt will be given to you, which in fact I must not call as a mixture analysis. I must call as identification of cations and anions, because now the mixture is not here. It's only a one salt. So it won't be a proper way to write down mixture analysis, but it starts from the class 11 and go to the higher education when you will be doing right up to the MPhil level. This analysis will continue with you. So we are taking that into consideration. So one cation and one anion will be given to you. As for example, suppose if I give you the lead nitrate salt. So what is the cationic part over here? Lead. What is the anionic part over here? Nitrate. Anions are acidic radical. Cations are basic radical. And we will be identifying anions and cations by performing a test. As I have already told you, you are the luckiest of a batch in this manner. In this method, that we have to identify only one cation and one anion. Otherwise, the earlier batches have, as by the syllabus, identified two cations and two anions, which becomes a difficult analysis. Not even in the college level, the students are able to determine that. But you will be. Just follow the way I will be demonstrating the practical to be done. Now, all of you, please check, you have got this study material with you. This has been provided to you because in this lockdown time, I think many of you must not be having the practical book. Yes? So that is why this study material is being provided to you. You have to keep it with you at least up to the final board examination, from where you can learn the test. This is one practical where the test is to be given. This is one practical where the test is to be given. You have to learn these tests. Am I clear? Now, what is to be done over here? In this anion analysis, just see very carefully how it is to be done. The analysis of anion, just see your study material, is to be done by using an aqueous solution or sodium carbonate extract. The question is, how do we prepare the aqueous solution? It is very simple. Take a test tube. To the test tube, add salt and water. Aqueous means water solution. Add water, heat and filter. The filtrate will be called as a aqueous solution. In almost all the tests given in this study material to you, you will be identifying the anions by use of a aqueous solution or sodium carbonate extract. You may see after the aqueous solution, here it is given a sodium carbonate extract. Now, how to prepare a sodium carbonate extract? What you have to do? You have to take a china dish. China dish is a porcelain dish, this dish. You have to take a china dish. In this china dish, you take a salt and then add sodium carbonate. Since we are preparing the solution in sodium carbonate, that is why it is called as a sodium carbonate extract. Am I clear? And then add water to this to fill it to more than half of its capacity. When it is filled to more than half of its capacity with water, you have to heat it to boil. When it gets boiled up, you filter. Filtrate will be called as a sodium carbonate extract. Am I clear? It is in these aqueous solution or in the sodium carbonate extract that you have to carry out the test for the identification. Am I getting clear? Now how? You may see first one is the test of a carbonate ion. This is a very simple test which you have been doing since the class 9. What you do? You take a salt. To the salt or salt solution you may take, that is an aqueous solution. You add dilute HCl. Which gas will be given out? Carbon dioxide. Pass the gas through lime water. Lime water will change to milky. The gas is colorless, odorless and changes the moist blue litmus paper to red. So this is the test of a carbon dioxide. Similarly, you may see over here, the test of sulphide is given. Just see very carefully. What is given over here? To the part of a soda extract. It is written over there. The soda extract is this. In fact, the right word should be sodium carbonate extract. Soda extract is used in the organic chemistry, which is called as the Lazine filtrate. Here you have prepared the solution in a sodium carbonate. So this will be called as a sodium carbonate extract. But since in 95% of the books you will be seeing it, they are not just taking care of this mistake, they are making regularly. Soda extract means a sodium extract in a sodium metal extract, that is. This is a sodium carbonate extract which is prepared in the sodium carbonate. Now, this sodium carbonate extract is to be taken. Now, to this sodium carbonate extract, what test we have to perform for the identification of a sulphide anion? You know from the class 9, sodium carbonate extract, to this we add dilute acid, either H2SO4 or HCl. A sulfur dioxide gas will be given out, which is a suffocating odor gas. Pass the gas through KMnO4 solution. It will decolorize the pink or the purple color of a KMnO4 solution. Remember those tests? All the tests are written over here, students. Carbonate, sulphide, sulphide. In this case, H2S gas will be given out, which again will be a rotten egg smelling gas. Then nitrite, you may look at the next page. Then the test of a nitrate, chloride, bromide, iodide, acetate, oxalate, sulfate and the phosphate anion. Today, since you are doing it for the first time, I have given to you a nitrate anion. I will be demonstrating to you how do we identify the nitrate anion also. Am I getting clear? So out of all these, today I am telling you which salt is being given to you. In the further, whenever you come next to the lab, the salt will not be told to you. You yourself have to identify it. But since today is a demonstration day and the first hand experience of yours in this practical for the first time in the lab, what we will be doing is we are telling you the name of the salt. You will be identifying these because you know this and will try to learn the procedure today. Main important thing is that you learn the procedure today. So today what we have given you, we have given you the nitrate salt. Am I clear or not? Now, one anion nitrate is to be given, which is you are told and you will be doing a practice for identification, for practicing for the process mainly, or procedure is to be learned today. Then one cation is given to you, and that is of course a lead. But then if you look at the next page, this is very important. the identification of cation is to be done. Student, in the identification of a cation, you have to follow the 4 steps. How? Just I am reading from your study material. The sequence of various steps involved in the systematic analysis of a basic radicals are as follows. Number 1 is the preparation of the original solution. So in this first, over there we prepare the aqueous solution or the sodium extract. Here we have to prepare the original solution. How do we prepare the original solution? We will take a salt. To the salt we add water. When we add water to the salt, the solution prepared is an original solution. It may be possible that the salt may not be soluble in water. If the salt is not soluble in water, then you can add dilute HCl to this in the first step. If it's still not soluble, you can add concentrated HCl. If it is still not soluble, you may add concentrated nitric acid into that. But I will suggest you to proceed only with this part. Because dilute HCl, H2SO4 or concentrated NO3, what is to be added, that will come in the part of a process. Am I clear? When we will be carrying out the practical, naturally at various steps, wherever data is needed, that will be added. So your simple word over here is, when you prepare the original solution, dissolve the salt in water to prepare the original solution. Am I getting clear? Salt is to be dissolved in water to prepare the original solution. Now, the various cations in the syllabus are classified into various groups. These are ammonium, lead, copper, ferric, aluminium, manganese, nickel, cobalt, barium, strontium, calcium and the magnesium ion. How do you do this? You may look at the table given to you. Look at this table provided to you. Now see over here. What do we have? We have our original solution. We prepared this solution. Am I clear? To this solution, we add dilute hydrochloric acid. Dilute hydrochloric acid is being kept in the wash bottle, this bottle. From here you have to add. It will be kept on the either side of the reagent shelf and you have to add it from there. So to the original solution, you add dilute HCl. When you add the dilute HCl, white precipitate will be obtained. If the white precipitates are obtained, it indicates the presence of a group number 1. Am I clear? Then you filter. When you filter, the residue will be used for the identification of a cations present in the group number 1 and the filtrate will be used for the group number 2. In the group number 2, we have a lead and the copper ion. Suppose in the group number 1, the lead is obtained. So your practical is over. Before that, you have a 0 group also. And how do we carry out the test of a 0 group? This is from the class 10. We take a salt solution. To the salt solution, we add sodium hydroxide. We heat. Which gas is given out? Ammonia. Bring a glass plate dipped in HCl over it. You will observe the dense white fumes of ammonium chloride. Remember, the test is also given in the study material provided to you. What you need to do is, you have to study it very thoroughly. Today you will get a first-hand experience of this. After going home, after conducting this experiment, your aim will be to read it and understand it very thoroughly. So that whenever you come next to the lab, you are able to perform the practical properly. Fine. Now, after the dilute HCl addition, if the white precipitates are observed, it indicates the presence of a group number 1. Then filter. Filtrate will be carried for the 2nd group. Residue, we will be carrying out the test for the lead ion in the group number 1. Am I getting clear? Now, after this is being done, to this filtrates to obtain, you pass H2S gas. Now, if suppose the lead ion is obtained in the 1st group, no need to go for the 2nd group because now in the syllabus we have only 1 cation and anion. Earlier day, a year or back or 2 years back, we have 2 cations and the 2 anions. Suppose first is a lead ion, the 2nd is the magnesium ion. So you have to go for the entire process. Now, here suppose you obtain the lead ion. So why to go for this? The practical is done. Now, if the 0 group is absent, 1st group is absent, then you have to carry out the test for the 2nd group. Test for the 2nd group will be carried out by the use of a filtrate of the 1st group. Am I getting clear? Or you may also prepare the original solution again. Both the options are possible. Here you either use for the identification of copper ion, you use the original solution. How did we prepare the original solution? Original solution plus dilute HCl, white precipitate obtained or not obtained. In this case now, if this is absent, then no precipitate will be observed. So no need to filter. Directly pass H2S gas into this. If the precipitates are obtained, a chocolate brown color precipitate or brown color precipitates are observed, this will indicate the presence of group number 2nd. Just see in the notes, filtrate and pass the H2S gas. black or yellow or the brown color precipitates are obtained, which will indicate the presence of a group number second. If group number, then filtrate will be kept for the third group and residue will be used for the test of a second group. In the filtrate, you may add boil of H2S, heat of concentrated nitric acid, and add pinch of ammonium chloride and ammonium hydroxide. Am I getting clear? If the second group is also absent, you may also carry out the practical by using a original solution. Then again filter, precipitate, if observed, will be for the third group, and of a third groups are observed. You will be carrying out the test for the third group, and if not, the filtrate will be used for the fourth group. You may again carry out the test by use of a original solution. Either through a filtrate, you pass H2S gas, or in the original solution prepared by carrying out the process again, you pass the H2S gas. This will indicate, if the precipitates are observed, it will indicate the presence of group number 4. And in the group number 4, what is to be tested? Manganese ion, nickel ion, and the cobalt ion. Am I clear? And zinc ion also. Manganese, nickel, cobalt, and zinc also. I have missed zinc over here, so this will be zinc ion also. Am I clear? Similarly, in the residue so obtained, the process will be given to you. You will be carrying out the further test. To the filtrate, you will be going for the test of a fifth group, where you boil off the H2S and add ammonium hydroxide and ammonium carbonate. Then similarly in the group number 6. In the Viva walk, you may be asked, name the group reagent of our first group, first group dilute HCl. Second group, H2S. Third group, we will be having ammonium chloride and ammonium hydroxide. Fourth group, ammonium chloride, ammonium hydroxide along with the passing of H2S group. When we go for the test of a fifth group, ammonium hydroxide and ammonium carbonate. All this you have to learn. Am I getting clear or not? Fine. Now student, I will try to demonstrate to you how to carry out the test. I will be demonstrating you how to carry out the test of an anion by making a sodium carbonate extract, and how to carry out the test for a cation by use of a original solution following this analysis scheme which is being provided to you. Am I clear? We will first of all demonstrate to you how do we identify anion. Student, we are aware with the apparatus, a test tube is stained with the test tubes. This is a Bunsen burner, a lit up Bunsen burner. You have to always heat on the blue flame, which is a non-luminous flame. Non-luminous flame means a non-smoky flame. Luminous flame means smoky flame. Now, what we need to do? First of all, we will carry out the test of an anion. Now, we take a test tube. In this test tube, we will be taking a nitrate salt, copper turning. We will be taking a nitrate salt. Am I clear? Is it getting clear to you or not? Then we will be holding this with the test tube holder. Just see how do I identify the tests. Am I clear? Into this, I will be adding a bit of a copper turning. This is copper turning. So this copper turning will be added to the salt. So I will take the copper turning, and copper turning I will add to the salt. Is it clear? And then add concentrated sulfuric acid. This is a concentrated sulfuric acid. When I add concentrated sulfuric acid to the salt, concentrated sulfuric acid is to be added to the salt. After adding concentrated sulfuric acid to the salt, we will heat it up. Am I clear? When I heat, you will observe a reddish brown gas given out. When I heat it up, a reddish brown gas will be given out. You may see the reddish brown gas coming. This reddish brown gas is of a nitrogen dioxide. And the anion in the given over here is a nitrate anion. Am I clear? If you look at your study material, you will be able to find out this was the test number 2 for the identification of the anions. Getting it clear or not? given on the page number 2. First test on the page number 2 is a nitrate anion. You may see those tests. Is it clear? Now the second test of a nitrate ion is to be done by use of a sodium carbonate extract. How do we prepare the sodium carbonate extract? This is a gas burner. We'll put a tripod stand over here. Am I clear? Now we'll take a china dish or the porcelain dish. In this china dish, we will add a salt and sodium carbonate. In what ratio? In the ratio of 1:3. 1 part of a salt I'll take and 3 part of a sodium carbonate. So I've taken 1 part of the salt and 3 part of sodium carbonate I will take. Am I clear? I'll take 1 part of the salt and 3 part of the sodium carbonate. You may see over here in the china dish what I have taken. A salt which is being provided to you. To this I have added sodium carbonate. Now to this water is to be added. Am I getting clear? I'll add water to this. Fill it about half of its capacity and keep it to boil. Keep it to boil. When we keep it to boil, we will heat it till it get boiled. In the meantime, it get boiled up. I'll again demonstrate to you the same part which I have done earlier also. What we have done, we have taken the salt, fine, having a nitrate ion as earlier demonstrated also. To this lead nitrate salt, then to this we have added the copper turning again. Again I am demonstrating to you. To this we add concentrated sulfuric acid. Burner. We'll add concentrated sulfuric acid. Concentrated sulfuric acid is added to this. When I add the concentrated sulfuric acid, you may again see, student, I'll demonstrate to you again how do I carry out this test. We heat it again. Just see what gas will be given out. A reddish brown gas will be given out. And this reddish brown gas is of a nitrogen dioxide. Can you see this? This indicates the presence of a nitrate ion in the given salt. Second demonstration I will give you, and that will be by use of a sodium carbonate extract. Name the reddish brown gas, nitrogen dioxide. Fine, it is a nitrogen dioxide. Then what we will do? Now we will be carrying out the second test to identify the nitrate ion, and for that we will be using a sodium carbonate extract. How? I have taken the salt into this and then added a sodium carbonate into this in 1:3 ratio. I will heat it to boil and then filter. When I filter, residue will be separated out in this case, which will be discarded, and filtrate will be used for the test of a nitrate. And that filtrate will be called as sodium carbonate extract. In this I will need to filter. How will I filter? This is a filter paper, student. Fine. And this is a funnel. It is to be put into this. How? A filter paper, you make a first fold of this. There are 2 layers after making a first fold. Then make a second fold of this. How many layers will be there? 4. With every fold there will be 2 layers. Now open up one of the layer this way. Can you see this? It has become a cone. Now put this cone in a conical flask like this, so that it properly stick to it. Am I clear? Now I will be filtering through this system. A funnel having a filter paper in it. What I will be doing over here? In this case, what is to be done? I will take this solution from the sodium carbonate extract, or this which is being heated up in the china dish, and try to filter it up. How I filter? I'll put up this setup in a test tube like this. Am I clear or not? And then filter it up when I find out it gets properly heated up. Once it gets properly heated up, it is to be filtered. You have to be very careful so that you do not get burned up. Now I have to pick this china dish. To pick this china dish, I need an apparatus. Just see this. This is a tongue kept over here. This is a tongue. You will be using this tongue to pick. Don't pick it with the hand. It is heated up now. So you may get burned up. Am I clear? You have to carry out the practical with utmost confidence. There is nothing in this. Then once it gets heated up, I will filter. The residue for the anions is to be discarded, and the filtrate will be called as a sodium carbonate extract. It is in that filtrate I will be carrying out the test. Since it is a nitrate ion, now I will be demonstrating to you how to do the ring test. What is to be done in the ring test? Either I take the aqueous solution or the salt. To the salt, here I will be taking a sodium carbonate extract. To this sodium carbonate extract, I will be adding freshly prepared ferrous sulphate solution. Ferrous sulphate solution, for me it is kept over here, for you people it is kept over there. Today it will also be kept over there, because it is the last demonstration of mine in this lecture. Then to this we will add ferrous sulphate solution and then concentrated sulfuric acid from the side of the test tube. When we add concentrated sulfuric acid from the side of the test tube, what do we observe? Reddish brown ring will be observed at the junction of the two liquid. And when the reddish brown ring will be observed at the junction of the two liquid, it will indicate the presence of a nitrate ion in the given salt. Am I clear? You have to observe since it is heated up. Now, I am utilizing this time gap, that is the time it is taking up to heat up, to demonstrate the lecture to you, or to give a lecture to you how you have to carry out the practical. But while doing the practical, while you will be doing a practical, you don't have so much of a time. So what you will be doing, in the meantime it is getting heated up, you will be carrying out the other tests, so that the time is not wasted in the examination. You have 3 hours. In 3 hours you have to do a titration, you have to do the organic analysis, and have to do the mixture and the salt analysis. So better word here, instead of writing the mixture analysis, would have been the salt analysis. Am I clear? Mixture would have been when there are mixing of 2 or more than 2 salts. Since over here it is only 1 salt, so it can be better called as a salt analysis. Now what I will do, once I find up it is heated up, I will pick this up with the help of a tongue. You have to hold it tightly, because these are you have to hold it very tightly so that it does not split up. If it gets split up, it might split up on your hand or on the body part or on your clothes. If that happens, immediately tell me. You will be 100% safe. There is no problem. Fine? They will be 100% safe. But the best safety is a precaution. So you have to take all the precautions so that does not get burned up. You hold it up. Hold it up tight so that it does not split up. Hold up tight. Instead of introducing these fingers into the spatula, I'll suggest you to hold it from the outside. Am I clear? And then you start filtering. You start filtering it up. The filtrate will be called as a sodium carbonate extract. The filtrate so obtained will be called as a sodium carbonate extract. Am I clear? It is in this filtrate I will be carrying out the test, and the test of the anion will be carried out. Is it getting clear to you? You may see it is getting filtered up. It may get filled up very quickly, so you may change the test tube also. This is the way to do it. Am I clear? Now, this so obtained is sodium carbonate extract. In this extract, almost all these 12 practicals are to be carried out, or 12 identification of anions are to be carried out. So you need to be very careful. Now what we do? We take some of the sodium carbonate extract in the test tube, a bit of a sodium carbonate extract in the test tube, and I'll try to demonstrate to you the test of an anion. We have taken the sodium carbonate extract in the test tube, and then to this sodium carbonate extract, I'll add freshly prepared ferrous sulfate solution. You may ask the question, sir, why freshly prepared? Ferrous sulfate solution, if not freshly prepared, it may get oxidized to form ferric sulfate. And ferric sulfate will not be giving a reddish brown ring. The reddish brown ring is of what component? Nitrosoferrous sulfate. So if it is oxidized to ferric sulfate, the reddish brown ring will not be obtained. Am I clear? So here what we need to do is, we'll add in a controlled manner a bit of a freshly prepared ferrous sulfate solution. Add it. Yes. Now to this we will add concentrated sulfuric acid from the side of the test tube. And when we add concentrated sulfuric acid from the side of the test tube, let us see what happens. You may see the reddish brown ring. Just see very carefully in the middle of this. Yes, this if I shake up and if I move, the ring will dissolve. So that's why I am not moving. So this reddish brown ring is an indication of a nitrate ion. And this reddish brown ring, you may see it is still visible. Yes? Now if I shake it up, the reddish brown ring is gone. Why? Because when you shake it up, the reaction is exothermic. The heat liberated breaks the bond between nitroso group and a ferrous sulfate, which will break down. And that is why the ring is not obtained. The reddish brown ring obtained was of what component? It is nitrosoferrous sulfate. On shaking, the heat is liberated. The liberated heat will break this bond. And when it will break this bond, the formation of nitrosoferrous sulfate is not there. When it is not there, you will not be able to absorb the reddish brown ring. And that is why I am saying that your hand must be stable. Do not shake. The students are generally in the habit. Nothing is happening, they start shaking the test tube. Fine? So that will in fact finish up your work, what we have done for the identification of a nitrate ion. Similarly, there are 12 radicals in the syllabus, anions, 12 acidic radicals, which you have to identify. You will be getting one definitely from there. Am I clear? Suppose we have to carry out the test for a chlorine. What is the test for chlorine? Take a manganese dioxide, add concentrated HCl, greenish yellow gas will be given out, and that will be chlorine. What is the difference between carbon dioxide and sulfur dioxide? Carbon dioxide has no effect on the KMnO4. Sulfur dioxide changes the purple color of the KMnO4 to colorless. Carbon dioxide has no effect on the potassium dichromate. Sulfur dioxide changes potassium dichromate to green in color. The test must be on the tips. If you can learn the test properly, it is only then you will be able to perform the practical. Am I clear or not? And the same knowledge you will be carrying when you go for the higher education. Fine? Then you will remember how I explained this practical. No one will explain you to this right up to the MPhil level. This is how it is to be done. Am I clear or not? Now the identification of an anion is clear. Today it is being told to you which anion is this in your laboratory. Am I clear? Now I will be demonstrating to you how do we identify the cations. The various cations that we have in the syllabus are of a zero group ammonium ion, lead ion. In the second group we have a lead ion and the copper ion. Third group we have a ferric ion and the aluminium ion. Fourth group I have got manganese, nickel and cobalt and zinc. Fifth group barium, strontium, calcium, and the sixth group will be a magnesium ion. Now how the test of this is to be done? It is to be done by the use of original solution. How do I prepare the original solution? I'll again take the test tube. Now see very carefully. We will take the test tube, and in this test tube we'll take a salt. We have taken the salt. You just look at your study material, the table that is being provided to you. What is to be done? We'll take the salt. To the salt, just see very carefully, we will be adding dilute HCl. Fine. How it is to be done? First of all, the original solution is to be prepared. Just see over here, students. We'll take a salt. To the salt, we will add water. Am I clear? We have taken the salt, and to the salt, we have added the water. Now, original solution is ready. In the study material provided to you, it is given. If it is not soluble, as it is not soluble over here, add dilute HCl. If it is not soluble, add hot and concentrated HCl, then nitric acid. But in a first group, if we consider, you may look at the group reagent, it is dilute HCl. So we have taken the salt, we have prepared its solution, and then added a dilute HCl into this. Is the white coloration obtained, or the white color precipitates are obtained over here? Yes. I expect all of you know what is the difference between the precipitate and the clear solution. Do you know? I hope so, that you must be knowing. So you can see over here, the filtrate, the precipitates are settling up. Am I clear? The observation of the white color precipitate indicate the presence of a group number 1. Now, in the group number 1, what is present? Which cation? A lead ion. So I need to carry out the confirmatory test of a lead. How will I carry out? I will filter this solution. What I will do? I will filter this solution. So filtration again will be done in the similar manner that we discussed earlier. I'll take a filter paper, make a first fold of this. After making a first fold of this, I'll make a second fold. Am I clear? This will be a then I'll filter it up. How do I filter? I'll put a test tube below it. Yes, and add to it a solution, original solution, in which dilute HCl is added, so that it starts filtering up. Am I clear? The filtrate will be kept for second group, but the residue will be observed, will be used to carry out the conformity test of a lead. And what will be the precipitate called over here is, since it is containing lead in the group number 1, white color precipitates are observed by adding dilute HCl. So these precipitates will be of a lead chloride, PbCl2. So if I add this, now I'll filter this. If something is left in this, you may also again add bit of a dilute HCl or a water into this and filter it again, so that the entire filtration is done very, very effectively. Am I getting it clear? The filtrate will be kept for the second group. If the first group is present, you need not go into the second group, but in the examination you may be asked to at least write down this make the analytical table, so that can be done over there. Is it clear? You may see it has started filtering up. Can you see that? Now, once you filter this up, collect the residue. You have to collect the residue for the analysis of a cation. I'll be analyzing the lead ion into this. The important thing is, how do you collect the residue? Now, see very carefully. You must observe whether it has got filtered or not. You may see over here, a residue is observed. Yes or not? White color residue. In this residue, we'll be carrying out a test of a lead ion. So I need to collect this residue first of all. I'll take out this. You may see this one. Open up the layer slowly. It may get teared up. So there is nothing to worry about even if it gets teared up. You may see the residue over here. Yes or not? Now in the clean test tube, you have to collect this. Collect this residue. This way. Collect the residue in a clean test tube. Is it getting clear? Yes or not? Now, these are the residue of lead chloride. We all know that the lead chloride is soluble in hot water. We have studied in the class 10. Name the metal chloride which is soluble in the hot water. It is lead chloride. So we'll take the test tube and heat the water. By holding with heat this water. And then we will dissolve the residue in hot water. Heat it up. Is it getting clear? You have to heat the solution. When you find that it has got heated up, you have to add water into this. Add water to this. So as to dissolve the lead chloride. We all know lead chloride is soluble and soluble only in the hot water. Is it clear to all of you? We all know that the lead chloride is soluble and soluble in the hot water. So once it gets soluble in the hot water, you have to take that solution. This is a solution of a lead chloride. Fine. It's a solution of lead chloride. You may slightly heat up this also. Now, when it gets heated up, what you need to do is, you divide this solution into two parts. This is a solution of a lead chloride. Divide the solution, hot solution, into two parts. To the first part, we will add potassium iodide. You may look at your study material also. The conformity test of a lead is given. Divide the solution into two parts. Am I clear? Once you divide the solution into two parts, what you have to do is, just see over here now, you have taken this solution of lead chloride in the hot water. It is to be done, what is to be done? Now to this, you will add a potassium iodide solution. When we'll add a potassium iodide solution to this. Just see this. This is a potassium iodide solution. You will observe a yellow coloration will be observed. What you will observe? A yellow coloration. That will indicate that the given salt solution contain or given salt contain the lead ion. You may see the yellow color. So this is a conformity test given to you in the study material. So this shows that this contains the lead ion in the given salt. Just see is it getting clear or not? Similarly, you will be able to obtain the test. The clarity with which I am able to obtain the test with no error. Similarly, if you practice, the same will be with you. Now, we'll take the second test tube. In the second test tube, what is to be added? We'll add potassium chromate. This is the second test tube. In the second test tube, we will add potassium chromate. When we will add potassium chromate to this, here again the yellow color will be obtained. You may see. It means lead is present in the given salt. So which is the cation you are observing? Lead. Which is the anion you are observing? Nitrate. So salt will be lead nitrate. What was the aim? To analyze the salt. Which salt we have analyzed? A lead ion and this. Now you may see these are the two. These are the two different yellow colors obtained. One is a mustard yellow. Mustard you know, na? Sure? Have you seen the flower of a mustard? It is yellow in color. Even if you have not seen, it is yellow in color. Sarso in Hindi it is called as. Fine? Sarso ka fool. So it is yellow in color. This is a mustard yellow and this is similar to the uniform of a policeman. A khaki color. You may see this. Fine? So this will be two distinction. This confirms the presence of a lead ion. Is it clear, student? Now see one more thing. If suppose the group number 1 is absent, so lead is not present, what we will do? We will shift to the group number 2. How do we shift to the group number 2? we over here, what we do in this group number 2, what is to be done? We will pass through this filtrate the hydrogen sulphide gas. Color observed will be black, yellow or brown, which will indicate the presence of group number 2. Since in this salt I have already identified the lead ion, so naturally the group number 2 will not be coming. Am I clear? You may see over here how to pass H2S gas. This is hydrogen sulphide. This apparatus is called as the Kipps apparatus. You have seen in the lower classes, in which we add zinc sulphide or iron sulphide and add acid into this. So H2S gas will be given out. Now through this filtrate, you may also take original solution if the first group is absent. You pass H2S gas. When we pass H2S gas, on passing H2S gas, if you may see over here, the H2S gas is passed. Just see. Yes. Is any brown color obtained? No. Is any black color obtained? No. Yellow color precipitate obtained? No. So second group is absent. Am I clear? Otherwise, if it would have been obtained as a precipitate, you will again filter, keep the filtrate for the third group. This residue that will be obtained, you need not carry out the test of lead again, because lead is already identified in the group number 1. You will carry out the test of a copper ion. And to carry out the test of a copper ion, you dissolve the residue solution in nitric acid, 50% nitric acid solution, separate this into 2 parts. To the first part, you add potassium ferricyanide. What you will observe, you will add, when you add potassium ferricyanide, chocolate brown color will be obtained. And when you add ammonium hydroxide, bluish white precipitate, which are soluble in excess of ammonium hydroxide, which you have done in the class 10. In the similar manner, you will continue with this process up to the group number 6. Starting from 0 group to 0 group is a separate test. That does not come into this separation of a group analysis. So 0 group you can separately carry out. Take a salt solution, to this add sodium hydroxide, heat, ammonia gas will be given out, bring a glass cloth dipped in HCl over it, dense white fumes of ammonium chloride will be obtained. I think you must be very clear. Now student, today you have been given the salt just to have a first hand experience how to carry out the procedure. Even if you obtain or correctly identify nitrate and the lead salt, I will suggest you to go through a process so that you get comfortable whenever you come next to the lab. Am I clear? With this, I hope you will be doing your work properly, so you may start your work.